Here we have a rational function with x cubed minus 2 divided by x squared minus 4. For asymptotes, there's two kinds. One is vertical asymptotes. That's where the function is going to be undefined because of division by 0. So for vertical asymptotes, simply set the denominator equal to 0. You could then factor or use quadratic formula or whatever method to solve for x, and we would find out that at x equals 2 and x equals negative 2, the function is undefined. It's going to have vertical asymptotes there, or at least possibly have vertical asymptotes there. I'll get to that in a second. Now the other kind of asymptote is possibly there's a horizontal asymptote. But a horizontal asymptote comes from when you look at the leading terms or the most powerful terms and they are the same degree. So if it was x cubed over x cubed, that essentially equals 1, and y equals 1 is a horizontal line. Since this one right here reduces to be x cubed over x squared when you look at the highest power terms, and when you reduce that, the answer is x. Well, y equals x is not a horizontal line. That is a line that is at an angle or a slant. So there are slant asymptotes. And it's easy to remember. You just look at the most powerful term, x cubed, compared to the most powerful term in the denominator. And if this one has degree that's bigger, then there's going to be slant asymptotes. And in that case, what we do is long division. Divide x squared minus 4 into x cubed minus 2. And let's see, so we'll go x times, multiply this out, there's going to be x cubed minus 4x, and then subtract. So the x cubes will cancel, the 4x becomes positive, and then I just bring down the negative 2. Next, how many times will this divide into this? It won't. And so we're done. So that means that the answer was x, and then the remainder of 4x minus 2 over x squared minus 4. So, as far as an asymptote, that means that it's just y equals x, and the remainder part doesn't matter. In fact, when I have my students do slant asymptotes, they say you don't even need to find the remainder, you just need to know how many times to divide in. So, when we go to look at the graph, so I want to see that we've done this correctly. When I look at the graph, x is cubed minus 2 divided by x squared minus 4. Then we've got vertical asymptotes at positive and negative 2. So that's what's happening here. There's a gap in the graph, and there's one over here at negative 2. Now earlier I said that it's possible that these are the vertical asymptotes. It's also possible that we did this work, and this work is correct, but one of these gets canceled, or maybe even both of them gets canceled. Well, that would happen if, for example, this top part said x cubed minus 8, because if it said x cubed minus 8 on the top, then we would have been able to factor this as x minus 2 times an x squared, etc., etc. And then this one could be factored as x minus 2 times x plus 2. So the algebra would have had those cancel. So this one, which gave us x equals 2, would have canceled. Now that's only if this was an 8 and this could have been factored. So in this case that didn't happen. As you can see, both of these asymptotes do show up on the graph. Also, this right here, the slant asymptote, well, we can check and see if we got that right. So what I could do is graph the line y equals x, and I'm going to make this sort of a dark line so you can see the difference. And then the idea of the slant asymptote, or the horizontal asymptote, is that if you were to follow the graph way out, so instead of in the tens, let's say it's in the hundreds. So if you zoom way out, then the function, this function, is going to be getting closer and closer to this. So this information is sort of a zoom in and see what's happening in the middle of the graph, or near the x-axis, near the origin. And then this is saying zoom out and see what's going on. So there's the function itself. And then here's y equals x, which is going right along there. So this part is right. Okay, then describe the end behavior. Well, the end behavior means as you go far, far out, what's happening to the ends. So it's the same as this, y equals x. So you can see the right side of the graph is going up forever, the left side is going down. Well, the proper way to say that is the right side means as x is going to the right, then the function was going up. F of x was going up forever. Then the other side. To say the left, we would say as x goes to negative infinity, then the function is going down. And that's everything asked for.